Hello everyone, I am Ansh welcoming you all to this channel Aaru Underway, your voyage to marine mastery. About Aaru Underway, this channel focus on IMU syllabus revised for 2026 batch and it is also applicable for 2024 batch, 2025 batch, 2027 batch and all the upcoming batches till the syllabus is same. In this channel you will get detailed maritime subject like navigation, engineering, seamanship. You will also get real sea life experiences and career tips. This channel helps aspiring mariners to build their strong foundation. Your journey to maritime excellence begins here. So today we will study the continuation of the unit 1 in the fluid mechanics, fluid property and its measurement. So today our index is 1.6. Today we will study about the pressure measurement and then we will see the construction and working of piezometer with simple diagrams. And next we will see construction and working of manometer with simple diagrams. And in the last, construction and working of simple barometer with simple diagram. And we will solve some MCQ related to P by Q and the MCQ that can come in your semester exam. So first one is piezometer. So what is piezometer? So piezometer is the simplest form of manometer. Piezometer is the simplest form of manometer used to measure moderate pressure of liquid. Means it is a device used to measure the pressure of the liquid. Means pressure head. This is the pressure head. This device means piezometer consists of a glass tube inserted in wall of a vessel or a pipe containing the liquid whose pressure is to be measured. It means the piezometer is a means piezometer consists of an inserted wall of vessel in which the liquid is filled and the pressure of liquid we can determine from this device. The tube extends vertically upward to a height such that the liquid can be fully rise in it without overflowing. So from this device piezometer we can find the moderate pressure of the liquid. Here from this diagram, this is the diagram of piezometer. Here you can write this formula heat equal to pressure upon a specific weight or weight density. So from this formula you can get P equal to rho gh because we know that this W means specific weight is equal to rho g. So if you put it in place of W, you will get E equal to rho gh. So in your examination they can ask it for in derivation for 3 to 4 marks because this is the simple one. So how we can derive it? So first in your examination you have to make this diagram and and in the starting of diagram you have to write some assumption or you can say that the things from the diagram. Like from this diagram you can write h equal to height of liquid in piezometer. And we can also write this W equal to a specific weight or weight density of the liquid. A specific weight or weight density of the liquid. Or you can say W equal to rho g. And we can write unit Newton per meter cube and here the unit will meter. And we can also write P equal to pressure of the liquid. and its unit is Newton per meter square. So from the previous slide, we can say that H equal to P by W, means height of the liquid equal to pressure upon a specific weight. So from here we can write P equal to HW, and we know that W equal to rho G. So what it will become, rho GH, since W equal to rho G. And we can write unit Newton per meter square. This is the only you have to prove. Now we will know more about the piezometer. Like here we have notation H equal to height of liquid in piezometer, pressure head, W equal to specific weight or weight density of the liquid, P equal to pressure head of liquid, and H equal to P upon W. Then you will get P equal to rho GH. Here are some disadvantages of piezometer. Like piezometer cannot measure the pressure of gas. It means it can measure the pressure of only liquid. It cannot measure high pressure of liquid. The tube would need to be impractically tall. It means if we want to measure high pressure, the pipe will be too much tall. So we can use for moderate pressure. It cannot measure the pressure of low pressure liquid accurately. Means it cannot measure very high pressure, or you can say high pressure or low pressure. It can measure moderate pressure. Now next is simple U2 manometer. Definition. A simple U2 manometer consists of a glass tube bent into U shape. It means this device is called U2 manometer because the glass tube is bent in a shape of U, like this. Like you can see here, this is in the shape of U. One end connected to the point where the pressure is to be measured, means this point like B, and here also B, and other remain open to the atmosphere, and other end is open to the atmosphere. A heavy manometric fluid, a heavy manometric liquid, commonly mercury, is used inside the U2. It means like here is a lighter liquid, you can say water, and this will be the mercury, or you can say the heavy liquid. And remember this one, like if you have to find the density, you can use this formula. Or density equal to specific gravity into 1000, you will get the density. And here you also know that P pressure equal to rho GH. So there are two type of simple U2 meter. First is gauge pressure, means for the gauge pressure simple U2 manometer, and for vacuum pressure simple U2 manometer. So we will study one by one about this. U2 manometer, positive gauge pressure. So this one is the gauge pressure where the liquid is above this datum line AA, and for the vacuum pressure the mercury is below this datum line. So here are the some notation, and this is the final formula for this simple U2 manometer for gauge pressure. So we have to derive this. So here you can say some notation like H1 is the height of liquid in the left limb above the datum. H2 equal to height of the liquid in right limb above the datum. And S1, S2 is the specific gravity of the light liquid upon heavy liquid. No, S1 is the specific gravity for the light liquid and S2 equal is the specific gravity of the heavy liquid. And here rho 1 is, and here the rho 1 equal to S1 into 1000 to find the density of the light liquid, and rho 2 is equal to S2 into 1000 to find the density of the heavier liquid. Balancing pressure at datum, you can say A here. So pressure intensity in the left limb is PA, means the pressure of this. Here it is written B, you can say here it is A. So for this point there is a pressure PA, and for this tube of the left limb we can say the pressure in this rho 1 GH1, means the density of the fluid in this column is rho 1, and due to gravity, and the height H1, and the pressure intensity in the right limb is the density of this column, means this liquid, that is rho 2, and G is the gravity, and H2 is the height. Since if we equate this pressure intensity in the left limb equal to pressure intensity in the right limb, we will get this formula, and from this we can write this one. So we have to derive this. So first we will derive the equation for simple U2 manometer at gauge pressure. So for deriving this, we will let some assumption, or you can say some notation. Let H1 equal to height of the liquid in the left limb above the datum line. Height of the liquid in the left limb above the datum line. In examination, you have to write all this sentence to get the full marks. And we can say H2. H2 equal to height of liquid in the right limb above the datum line. Or we can take S1, means a specific gravity of lighter liquid, and we can say H2 equal to a specific gravity of heavier liquid. And we can also say rho 1 means density of the lighter liquid, or we can write it S1 into 1000 kg per meter cube, and rho 2 density of the heavier liquid. And P equal to pressure intensity. So first we have to write all the notation, then we will come to the equation. Like first we will find the pressure in the left limb. So for pressure intensity in the left limb is equal to pressure due to this column means this height and pressure due to this point B. So we can write PB, or if in place of B, if it is there A, you can write PA. So this is that is the only point name PB, and in the left limb the pressure is due to this point B and this column. So we will add add them. So we will put a plus sign and write the pressure due to this column, that is rho 1, G and H1. And similarly we will find pressure intensity in the right column. In the right limb, so in the right limb, the end is open to atmosphere. There is no point pressure. So we can write rho 2 GH2. And if we equate them, we can write pressure intensity in the left limb equal to pressure intensity in right limb. So we can write PB plus rho 1 GH1 equal to rho 2 GH2. So we can write PB equal to rho 2 GH2 minus rho 1 GH1. And that is the derivation, or you can say formula for this, and its unit is Newton per meter square, where you can write P equal to rho GH Newton per meter square, density equal to S into 1000 kg per meter cube, and G equal to 9.81 Newton. Newton or meter per second square. So this is the final formula for the simple YouTube manometer at gauge pressure. So next is YouTube manometer vacuum pressure type, or you can say negative pressure. So this is the diagram for the vacuum pressure YouTube manometer, and this is the formula for this YouTube manometer. We will derive this. Okay, how we can derive this? So first we can say that a right limb open end is exposed to atmosphere. It means pressure intensity there is zero. Here this right limb have no fluid above the datum line, and it is open here, exposed to atmosphere. So here pressure intensity is zero. Then pressure intensity in the left limb is pressure due to this point B. Here it is written A. You can change it to B. PB plus pressure intensity in this pipe. So you can write it as density of this light water, rho 1 GH1, this one, and this mercury one, rho 2 GH2. Pressure intensity in the right limb equal to 0. If we equate this, both the limb pressure, so we can get PA plus rho 1 GH1 plus rho 2 GH2 equal to 0. And if we shift to the right side the equation, we will get rho 1 GH1 plus rho 2 GH2. So now we will derive it. So before and its derivation, we can assume some notation, like let first we take H1. H1 is height of liquid in the left limb above the datum line. So we can write H1 equal to height of the liquid, height of the light liquid in the left limb above the datum line. And similarly, you can write height of the heavy liquid in the right limb. In the left limb, there is a correction above the datum line. And you can let S1 equal to a specific gravity of light liquid or S2 equal to a specific gravity of heavy liquid. And rho 1 equal to density of light liquid and rho 2 equal to density of heavy liquid. And P equal to pressure intensity. So from here we can write pressure in left limb means this limb, left limb, equal to pressure due to point B plus rho 1 GH1 plus rho 2 GH2 and pressure in right limb equal to 0. If you equate both, we will get PV plus rho 1 GH1 plus rho 2 GH2 equal to 0. And we will get PV equal to minus rho 1 GH1 plus rho 2 GH2. And that is the final derivation of this. Next is U2 differential manometer. In this manometer, both side is connected with point A and point B, and this differential manometer is two type. First, when two pipe are at different level, and when both the pipes are at same level, like you can see in this picture and in this picture. So what the definition says? So definition is of this U2 differential manometer says it is used to measure the difference in pressure between two points. It means it is used to measure the pressure between two points, like here pressure point A and point B. And the second is it consists of a U2 containing a heavy liquid, which it's two in and connected to point A and B. It means it is containing heavy liquid that is in dark in color, and this is light liquid. This is heavy liquid and this is light liquid. So what we will do, we will see the derivation for both. So first we will see the U2 differential manometer at same level. Here the point A and point B are at same level. Definition: it is used to measure a difference in pressure between two points in pipe or in two different pipes. Consists of U2 containing heavy liquid with two ends containing NB. So we can write the notation like H1 equal to height of liquid in A side above the datum line, and H2 and h equal to height of the liquid in the right limb above the datum line. S1 and S2 is the specific gravity, and heavy liquid S1 is the specific gravity of light liquid, and S2 is the specific gravity of heavy liquid. This is the formula for this. And P and P equal to pressure intensity at A and B. And this is the final formula for this manometer. So what we will do, we will derive it. So we will assume some notation, like we can say let H1 equal to height of the liquid in the left column above the datum line. Height of the light liquid in left limb above the datum line, and H2 is similar. Height of the heavy liquid in right limb above the datum line, and we can let S1 equal to a specific gravity of lighter liquid, and H2 equal to a specific gravity of heavier liquid. And rho 1 equal to density of lighter liquid, and we can write the formula for this like S1 into 1000, and rho 2 equal to density of heavier liquid, and Pa equal to pressure intensity in left limb, and Pv will be the pressure intensity in right limb. So from the diagram we can write that pressure intensity in left limb equal to pressure intensity in right limb. So we can write pressure intensity So from diagram we can write that pressure intensity in left limb equal to pressure intensity in right. Pressure intensity in left limb, we can write pressure due to this point Pa plus pressure due to this height, and that height is h plus x, or in place of x you can also write h and h1. You can write anything, you can denote it by anything. So here what we will get, h plus h1. So you will get density of this, density 1 g and h plus x. And similarly, pressure intensity in right limb is equal to pressure due to point PB and pressure due to this pipe. That is PV plus rho 1 G X plus rho plus rho 2 GH plus rho 2 GH. So if we equate this both equation like pressure in left lane equal to pressure in right lane, we will get PA plus rho 1 GH plus X equal to PV plus rho 1 GX plus rho 2 GH. Here this lighter liquid is we are taking at X. The distance of lighter liquid we are taking X and the heavier liquid is H. And density for the lighter liquid is rho 1 and density for heavier liquid is rho 2. So from here we can solve it like PA minus PV equal to rho 1 Gx plus rho 2 Gh plus rho 1 Gh plus X. So we can write rho 1 Gx plus rho 2 Gh plus rho 1 Gh plus rho 1 Gx. So we can take common from these two one. Sorry, there is a mistake. Here it will come minus sign because we are shifting this PV to this side and this rho 1 Gh plus X to this side. So it will be minus rho 1 Gh minus rho 1 Gx. So this and this will get cancelled and we will get PA minus PV equal to rho 2 Gh minus rho 1 Gh, and if we take Gh common we will get PA minus PV equal to rho 2 minus rho 1 Gh Newton per meter square. And the next is two tube at different level means differential manometer means two pipe at different level. Here A is up above the B. So there is a difference in the level. So there is a similar thing like setup that you already know. And this is the final formula for this. That is the important one. So we will derive this formula. So in this case, similarly we have to write the same thing that we have written in the previous derivation. So H1 equal to right of liquid in left limb above the datum. H1 equal to height of the liquid in the left limb above the datum line. H2 equal to height of the H1 you can take H1 this one from this side to this side you can take it as H1 and this is H, and in place of Y you can also write Y equal to H2 because in some book H2 is given. So you can use both Y or H2. For the simplicity or your simpleness, here I am using H2 because everything will be in H. That will do not confuse you. So it will be H2. So in this place, in place of H1, H2, I will write H equal to height of the liquid, height of the heavy liquid in the right lane above the datum line. And you can write S1 equal to a specific gravity of light liquid, S2 equal to the specific gravity of heavy liquid. And rho 1 equal to density of the light liquid, rho 2 equal to density of the heavy liquid. Or PA is the pressure intensity in left limb and PB equal to pressure intensity in right limb. So we can write that initial intensity in left limb equal to pressure due to point A plus due to this side H1 and in place of Y we can write H2. So it will become PA plus rho 1 GH1 plus rho 1 GH. Because this is the total height and this height is H, so it will become H1. Pressure intensity in right limb is equal to PB plus rho 1 GH2 plus rho 2 GH. So if we equate this, that we will get PA plus rho 1 GH1 plus rho 1 GH equal to PB plus rho 1 GH2 plus rho 2 GH. PA minus PV. If we shift this PV and this both equation to that side, we will get rho 2 GH minus rho 1 GH plus rho 1 GH2 minus rho 1 GH1. So we can take common out from this, and what we will get, we will get, if we take GH common, we will get rho 2 minus rho 1 plus rho 1 G. We will get H2 minus H1. That is the final formula for this differential manometer at different level. And the next is inverter U2 manometer. It is used to measure the difference of two pressure where the accuracy is the major concentration. Means this inverter U2 manometer is used to measure the pressure difference at 2 points but with accuracy. So this is the point A, point B, and this is the notation like this heavy liquid that is rho 2 having height h, this whole length is h1 and this length is h. So it is similar to the previous one, like here the notation is same like h1 equal to height of the liquid in the left limb H2 equal to height of the liquid in right limb. H2, H here H1 and H2 is the same liquid. H is the height of light liquid in top bend below data. Here in place of light, it will come heavy because H is the distance of heavy liquid. In S1, S1, S2 is the specific gravity of S is the specific gravity of this top one, and S1 is the specific gravity of this left one, means this liquid, and S2 is the right liquid, this one. And this and this both liquid is same, only this is heavier liquid and the different liquid. P and P with the pressure intensity in left and right hand. And this is the equation we will going to derive this. So the final formula what we will get, PA minus PV equal to rho 1 GH1 minus rho 2 GH2 minus rho H GH. So we already know the notation. So we here we can write, or we can also write, let H1 equal to height of the liquid in the left limb below the datum line. H2 is the liquid height of the liquid in the right limb below the datum line, and only H is the height of the liquid in the right limb below the datum line, and S is the specific gravity of the liquid. We can write S1 as specific gravity of liquid in left limb, and S2 is the specific gravity of heavy liquid. Here this is the light liquid, and this dark pink is heavy liquid. And the density for this light liquid and this liquid is same, but this liquid the density will be something else. So we can say that rho 1 and that is rho 2. Rho 1 is the density of lighter liquid, and rho 2 equal to density of the heavier liquid. PV and PV already know, pressure intensity left and pressure intensity in right limb. So we can write here pressure intensity in left limb and right limb, and then we equate them. So in left limb what we can write, PA, and in place of plus we put here minus because this is the inverted one. If it is the vertical one we can place here plus, but in this inverted case we will put here minus. And what we write, rho 1 GH1, and pressure intensity in the right limb equal to PV minus rho 2 GH2 minus Rho X GH. We are taking rho 2 is this one, rho H, and this is rho 1. These two liquid can be same if it is mentioned in the question and may be different. Like this is the first liquid, this is the second liquid, and this is the third liquid. But most time this and this are same. But here I am solving with taking three different liquids that you will get the final formula that you can apply anywhere. And you can also mention it in place of rho 1, you can also place it rho x. So if we equate it, what we will get? We will get Ca minus rho 1 GH1 equal to Pv minus rho 2 GH2 minus rho s GH. If we simplify it, we will get rho 1 GH1 minus rho 2 GH2 minus rho s GH. And this is the final formula. Now next is single column manometer. So this is the diagram for the single column manometer. This is not very important, but we can also see this that by chance we are not leaving any topic. So definition say that it is a modified U2 manometer in which a shallow reservoir with a large cross section area about 100 into tube area is connected to one lane. For any pressure variation, the change in the reservoir liquid level is so small it can be neglected. Key advantage. Pressure is read from a single reading in the narrow limb only. One reading is needed for either type of single column meter. And these two are some assumption or you can say that we can calculate from this diagram. So here the notation that we will also write during the derivation of this, and this is the pressure balance, that's the equation, and this is the final answer that we have to prove. So how we can prove derive this or prove this? First we assume some notation like h1 equal to height of liquid in the left limb above the datum line. H2 equal to height of heavy liquid. Here it is light liquid, and this is height of the heavy liquid, and rest remain always same. Heavy liquid in the right limb above the datum. And S1 specific gravity of light liquid, specific gravity of light liquid. S2 is the specific gravity of heavy liquid. Rho 1 is the density of light liquid, and O2 is the density of heavy liquid. And PA equal to pressure intensity in del H. We can say fall of heavy liquid level in reservoir. And capital A equal to cross section area of reservoir. And small a is cross section area of tube. So now we can write a wall of heavy liquid. We will start from here and then we will go this side. Wall of heavy liquid. Liquid level in the reservoir. So we can write as area into del H equal to A into H2. So we will get del H equal to A into H2 upon capital A. This is the important for this derivation. And from here we can write pressure intensity in left limb is equal to PA plus rho 1 G H1 plus del H. And pressure intensity in right limb is equal to rho 2 into H2 plus del H. If we equate this, what we will get? We will get PA plus rho 1 G H1 plus del H equal to rho 2 G H2 plus del H. So we can write PA equal to rho 2 GH2 plus rho 2 G del H minus Q1 GH1 minus rho 1 that is rho 1 G del H. After solving this, we can write like from this and this and this in this. We will get PA equal to rho 2 GH2 minus rho 1 GH1 plus rho 2 G del H minus rho 1 G del H. So what we will get? We will get PA equal to del H. If we are arranging it, we will get del H rho 2 G minus rho 1 G plus rho 2 GH2 minus rho 1 GH1. And here the value of del H equal to A into small a into H2 upon A. So we will put it here. So PA will become A into H2 upon A bracket close into multiplication rho 2 G minus rho 1 G plus rho 2 GH2 minus rho 1 GH1. And this is the final answer. So next is the inclined single column manometer. So this is the diagram for the inclined single column manometer. Here this is a point PA, pressure due to point A, PA, and here is the angle theta, and this side is H2, and this saline height is L. So here are also some notation, or you can say we have taken from the diagram like H2 equal to L sin alpha, that will help us in proving this equation, and this is the final answer, or you can say the final formula for this inclined single column manometer. This all is the notation. Like here, H1 is the height of the liquid in the left limb above the datum line, and S2 is the height of the heavy liquid in right above the datum line. S1 is the specific gravity of the light liquid, S2 is the specific gravity of the heavy liquid, rho 1 is the density of light liquid, rho 2 equal to density of the heavy liquid, PA is pressure intensity, del H fall of heavy liquid in level in the reservoir, capital is cross section area of the reservoir, and small is cross section area of tube. This rectangle is the reservoir and this is tube, a small one. Alpha is the angle between horizontal and inclined tube from ground, and L is the length of heavy liquid moving toward the right limb. And this is a theory about this, like it is used to measure a small pressure with better accuracy, like it is very accurate. Means this type of manometer is used for accurate pressure measurement, and this is all the thing. And this is the key relationship that you have to remember. And this is the final formula for this. So how we can prove it? So first we can write fall of heavy liquid, fall of heavy liquid level in the reservoir is area into del H equal to A into L into sin alpha. And we know, and from the diagram we can say since H2 equal to L sin alpha, so del H will become A into L into sin alpha upon A. From now we can write pressure intensity in left limb is equal to PA, means pressure at point A, rho 1 G H1 plus del H. Pressure intensity in right limb will become rho 2 G L sin alpha plus del H. Equate this. If we equate this, what we will get? We will get PA plus rho 1 G H1 plus del H equal to rho 2 G L sin alpha plus del H. After simplifying it more, we will get rho 2 G L sin alpha plus rho 2 G del H minus rho 1 G H1 minus rho 1 G del H. Further simplifying, we will get rho 2 G del H minus rho 1 G del H plus rho 2 G L sin alpha minus rho 1 G H. If we take common del H, from first to we will get rho 2g minus rho 1g plus rho 2gl sin alpha minus rho 1gh. So the equation will become E equal to, and in place of del H we will put this one, del H equal to AL sin alpha upon A. So what we will get, AL sin alpha upon A rho 2g minus rho 1g plus rho 2g L sin alpha minus rho 1g H1, and this is the final derivation. Or you can, and also here is a assumption like here area capital A means capital A is very large as compared to A, like this is the this big reservoir and this is the tube very small. So here capital A is very larger than A. So if we take this, so if we compare the ratio of small a to A is very small and can be neglected. So neglected means the A is nearly, this small a is nearly equal to 0. So this term will become 0 and only this term will left. So we can also write rho 2gl sin alpha minus rho 1gh. So you can use both, also this one and also this one. Suppose if the value is not given or you are not able to find this small a, then you can use this formula. And this is the key formula summary that we have derived. Like here the piezometer. So the formula for the piezometer is P equal to rho gh, or here H equal to P upon a specific weight. And for the next one, simple util gauge pressure. So it is P equal to rho 2 gh2 minus rho 1 gh1. At vacuum pressure, P equal to minus bracket close rho 1 gh1. This all formula we have already seen and understood properly. So this is a summary of all formula. You only need the formula for solving the numerical derivation. They may be asked in your semester exam, but probably they will ask the numerical on it. Now come to the simple barometer. So this is the diagram of simple barometer that you can draw in the diagram in the exam. Like this is a beaker, or you can understand from this diagram. Like this is a mercury reservoir, and this is a tube that is inverted, and mercury is, and air pressure is acting this side and mercury is going upside. And here in this portion there is a vacuum, at sea level pressure it is 76 centimeter. So this diagram you can draw in the examination. Like this is the mercury reservoir, this, and this is the tube that mercury is going upside and atmospheric pressure is acting downward. So a simple barometer is an instrument that is used for measuring atmospheric pressure based on the balance between atmospheric pressure and hydrostatic pressure. Like it work on the balance between the atmospheric pressure and hydrostatic pressure of liquid column. An inverted glass tube containing mercury over a mercury reservoir. Its construction, glass tube, long है, narrow, uniform both tube, and one end is sealed. Like here the another end is sealed. This end is sealed, not open. So you can add glass tube, mercury reservoir, mercury column, scale, or support and level arrangement with the tube vertical and reservoir stable. And this is the formula like for the atmospheric pressure rho gh, and a standard pressure is H equal to
760 mm, that we can say 180. Means in the mercury, we can say in terms of mercury, we can say H equal to 760 mm of Hg, but in atmospheric pressure, we can say that 180 mm. Like both are the same. This is also the atmospheric pressure, but in terms of mercury, and it is in terms of air. So what is its working principle? Like when the tube is inverted into the mercury reservoir, mercury fall into the equilibrium is established. The space above the mercury column is nearly a vacuum, so its pressure is approximately zero. Atmospheric pressure acting on the reservoir support the mercury column at equilibrium. Atmospheric pressure is zero Gh, where P the mercury density, G is the gravitational acceleration, and H is the column height. For mercury, H equal to 7 mm at standard atmospheric pressure near the sea level. Operations and reading. How to use a simple barometer. Place the instrument vertically on a stable support. Keep the instrument on a stable support on a table. Ensure the mercury surface in the reservoir is exposed to atmosphere. Like this is the reservoir, so it is exposed to atmosphere. Read the vertical difference H between the mercury level in the tube and the reservoir level. Read at eye level to reduce parallax. Like you have to measure like something, like some suppose reading is here. So you have to see parallel to it, not from the upside or not from the downside to reduce the parallax error. Correct when high precision is required for temperature, local gravity, and capillary effect. What are these advantage, limitation, and application? Its advantage are simple in construction, direct physical principle, no electrical power required, reliable for laboratory demonstration. Its limitation is mercury is toxic, mercury is very harmful, glass is fragile, capillary temperature effect can introduce error. Weather use. Change in atmospheric pressure can indicate approx weather system. Scientific use establish pressure standard and demonstrate fluid statics. Modern practice digital and Android barometer are often preferred for portable and safety. So now we will see some MCQ that can be asked in your semester exam. So we will answer it one by one. So question number one is a piezometer is primarily used to measure. So we know that, and we also study that it is used to measure the moderate pressure of the liquid. Second question is for a piezometer, pressure head is given by. It is very simple. That is option B H equal to P by W. The relation between pressure and pressure head is. It is very simple. Option A P equal to rho GH. Which pressure cannot be measured through a piezometer? We study that piezometer is only used for measuring the liquid pressure, so gas pressure is the correct answer. Question number 5 is a simple U2 manometer has one end connected to the pressure point and the other end is. We know that in simple U2 manometer, one end is connected to a point but another end is open to atmosphere. So option B is correct. In a static manometer, pressure is compared by considering pressure intensity at same datum level. That is the B is the correct answer. Next question is for a positive gauge pressure arrangement, the pressure relation in the notes is. We have seen the positive gauge pressure means at gauge pressure, what is the relation? So we know that that is P A equal to rho GH2 minus rho GH1. So option A is correct. Next question number 8. Vacuum pressure is represented by a pressure value that is vacuum pressure above the atmospheric pressure equal that is below. So option C is correct. Question number 9. Sign of pressure in the vacuum. The relation is negative because it is simple because pressure is below the atmospheric pressure. Next question is a single column manometer contain a reservoir whose area is a single column manometer whose area is. So we can according to the much smaller than the tube, that is incorrect, equal to the tube area not much larger than tube. So option C is correct. Now the next is for the single column manometer in the notes given the level change relation. So we have already studied that it is del H equal to area into H. So option A is correct. An inclined single manometer is more sensitive because the distance moved by the heavy liquid is great. For an inclined tube, the vertical height component of L is L sine alpha. We have already studied it, so option B is correct. Question number 14. A differential manometer is used to pressure difference between 2 points. For a differential manometer point at the same level, the notes gives means the equation is. So this is P minus PV rho GH S2 minus S1. Option A is correct. Question number 16. When the two pressure tapping point are at different level, the pressure relation includes an only velocity at no, an additional elevation term yes, only at one no density term, that is only option B is correct. The inverted U2 differential manometer is stated to be used when we know that the inverted manometer is used for the accuracy. So option A is correct. In the notes, density is related to specific gravity by we know the density equal to S into 1000. The value of gravitational acceleration due to nodes using nodes that is 9.81. Option B is correct. And this is the last MCQ. Which device is specifically intended to measure pressure difference between 2 points? That is the piezometer, differential manometer, open tank, or single column. So this option is incorrect. You can get confused. But the question is asking which device is specifically intended to measure pressure difference between 2 points. So we have already studied that 2 point means differential manometer. Piezo point is one end is open to atmosphere. So thank you so much for watching this video, or thank you for staying with us at Aaru Underway. Your journey to mastering marine engineering has just begun. Subscribe, stay curious, and keep moving forward.